Okay, now we're going to move on to cross products. So we're going to kind of switch gears a little bit. And remember in, I think it was 7.4, we talked about dot products. Well, now we're going to talk about cross products. And what's different about a cross product is that your answer is going to be a vector. So with a cross product, the easiest way to explain this is not this. This is terrible. So those of you who have taken college algebra and you guys talked about the like 3x3 matrices and finding the minors and expanding the matrix, that's what we're doing here. So if you've taken college algebra, this should look very familiar to you. So I think the easiest way to do, instead of like, you're more than welcome to memorize this. I would not suggest it. The best thing to do is just to start with this problem and dig in. And I'm going to like kind of teach you as we go. Okay, so we are going to look at these two vectors. So vector V, another way of writing this is 2, 3, and 5. And another way of writing vector W is 1, 2, and 3. So that's the first thing that I want you to see. So what we're going to do is we are going to find vector, the cross product of W and V. So first thing we're going to do is set up this matrix. So I'm going to say IJK is going to go first, and then notice that W is first. So we are going to do, those first. So 1, 2, 3, and then I'm going to do V underneath that, 2, 3, 5. So I have this 3x3 matrix. Okay, so if you've taken college algebra, we are going to expand the first row. And if you remember how, like, when we do that, we have different signs according to the position. All you need to remember is plus, minus, plus. This is what we're going to do. And remember, so if you haven't taken college algebra, you're probably like, what are they talking about? Because it's really weird. It's really different, but it's really easy too. So I'm going to go along and kind of explain this. Okay, so to expand across the top, you are going to take, so I want to expand this. So we have to find the minor matrix to do and find the determinant of that. So the minor matrix, what we're going to do is we are going to cross out the row and the column connected to I. And that is going to create this new matrix. So I have 2, 3, 3, 5. Okay, so this is where those signs come in. So this is a minus, and so we're going to do the second one, J. And so, and so this next determinant, I'm going to cross out the row and column that it's in. This is a row, this is a column, I keep saying it backwards. And so I'm left with 1, 3, 2, 5. And so lastly, I'm going to, goodness gracious, I'm going to do plus K, and then do that last one. So this is K, so I have row and column. So I'm left with 1, 2, 2, 3. And so to find the determinant, everyone should have had just like a basic 2x2 determinant. But if you have forgotten, we're going to take this and multiply those together. So 10 minus, and then the product of this, 9, which is 1. So I'll do this in a different color. So 5 minus 6, which is -1, and 3 minus 4, which is negative. Okay, so we have this vector, and so it's going to be 1i, so just I, and then minus -j, so plus j, and then minus k. And this is going to be our new vector. And remember, we learned this in 2D space, that this vector here that we just found is orthogonal to these two vectors. So remember, orthogonal is a fancy word for perpendicular. So this vector is going to be perpendicular to this vector, and this vector is going to be perpendicular to this vector. And so we're going to prove that. Remember, in 2D space, we learned that if we found the cross product of orthogonal vectors, it equaled 0. So we're going to prove that by finding the cross product. Okay, so I just took the first vector, this one, and I just wrote it in just a plain form without the I, J, and K to make it more simple. And so I have 2 times 1, which is 2, and then I have 3 times 1, which is 3, and then I have 5 times -1, which is -5. So that does equal 0. And I'm not going to do it, but if I did the same thing to this one, and this vector, it would also equal 0. So I know I've just proven that they're orthogonal to each other. Okay, so now notice the difference. So direction count. So I did W times, or the cross product of W and V. I want you to do the cross product of V and W. So go ahead and do that on your own practice. It's really pretty easy once you get the hang of it and see what you. Okay, so here's my answer, and if you'll notice, so it's -I and then -J plus K, and the other one was +I plus J minus K, so they end up being opposites of each other. And again, this one is orthogonal to each of the vectors. So you're going to see this on a test, and I've already showed it. So basically what this is saying is just find the cross product. So, and it really, like, this one, I said order matters. Well, it doesn't matter to find if it's orthogonal or not. So you just choose which way you want to do it, and both answers, so, you know, both opposites answers would be correct. Okay, so I did this, and I did the cross product of U and V instead of V and U. Either way, it's going to be fine. If you happen to do the cross product of V and U, it would just be the opposite. So it would be I minus 2J minus 7K. So either one of these is just fine. They're both orthogonal to these two vectors. And that is it.